Hi, and welcome back. So in this video, I'm going to show you the Tenacity Library. As usual, the fully annotated Jupyter Notebook is linked below. It's in the GitHub repo, and I have the links to the library documentation, as well as how to install it using pip install. And basically, the website for the documentation is here. The library is called Tenacity. And it's basically a general purpose library to retry code. Very often, for example, if you're working with APIs and you're making calls, you may run into issues like, for example, rate limits or timeouts, and you want to retry your call, especially if it's a rate limit. And you want to retry it possibly using delays so that you don't retry like immediately, but you're going to wait a couple of seconds and retry. Or maybe you want an exponential backoff. So in a previous video, I actually showed how to write a custom decorator to implement retries on API calls. But this library really greatly simplifies the process with many additional features. And of course, it applies to many other use cases than just APIs. In fact, I'm going to do an example here mainly, and I will do some API examples as well towards the end, especially where I'm going to show you how you can completely customize, how the code gets retried or under what conditions the code gets retried, because you don't want to retry the code, all the time. It's only if certain conditions apply. So this library helps us do that and provides us a ton of built-in ways of doing it, but you can actually extend that yourself. It's not well documented in the documentation itself. So actually, I don't think it's documented at all in the documentation, but I will show you, if you stick around to the end, I will show you how to do that so you can really completely customize it. And so the first example I'm going to show you is actually going to use SQL, and I'm going to do something which is bad code. And before you start flaming me in the comments, I know this is a terrible design for this problem, and I'll explain what that is. But I know that, okay? I know that this design is bad from a database standpoint, but I just want to show you this retry functionality. And I wanted to do something other than API call because it is applicable in other places too. So let's switch to code and let's do some things. So the first thing is we're going to import Tenacity. That's the name of the library. So suppose that we have a system that maintains records for companies in a database. Now, each company has its own unique ID. And for some reason or other, that ID needs to be a random integer, not a UUID. So yes, from a technical standpoint, I would never design a database table that way. At the very least, if I really wanted a non-UUID key, let's say primary key for a company in my database, I might use a field that's auto-incrementing, an integer field that auto-increments, and you don't have to deal with the problem I'm going to show you here. But let's say that we truly want a random integer ID for our company. So one way of doing it would be to essentially supply the ID ourselves when we write the data to the database. But the problem is, well, that ID may already exist in the database. And so we're going to want to regenerate an ID and keep retrying until we find an ID that's not actually in use in the system, right? So again, as I mentioned, terrible design, but this is to show you the retriability with Tenacity, and it will allow us to dig pretty deep into it. So I'm going to import the SQLite 3 library, and I'm going to create a connection. Now I'm going to do an in-memory connection. So you could, of course, just specify here instead of this special string called memory. So this is going to be an in-memory only database. You could specify a file name. And I mentioned that in the notebook, which would actually save the data, persist the data to an actual file, right? But here, I just want to have a temporary database. I don't care about saving any of the results. So the first thing is I need to connect to the database. Second thing I need is what's called a cursor. So we're going to take this connection and we're going to call the cursor method. Now that cursor is what we're going to use to actually execute SQL. We're going to execute, select statements, insert statements, things like that. So for example, and I'm going to copy a lot of the code from the notebook. As I said, it's available in the GitHub repo. So here I'm going to create a table. I don't need to do a create table if not exists because this is an in-memory database that restarts every time. So I don't have to worry about that. So we're going to create a table. Table is called companies. It's going to have an ID field, a field named ID, which is going to be an integer. It's also going to be the primary key, right? Which means we cannot have duplicate IDs in this table. And then just another name for the company, and that's going to be a simple text field. So now we've created this table inside our database. Now we can easily query it. For example, let's say we want to fetch all the rows from the table. We can just say select star from companies. That will select every field and then every record in that database. So that's what we do through the cursor execute as well. You noticed we did the cursor execute as well. Here we're going to actually care about the results that comes back. Here we didn't. And we're going to then apply the fetch all method to say just bring everything back from that cursor. And so of course when we do that, there is nothing there because, well, we just created the table. It's empty. So let's add some data to it. And to do this, I'm going to generate 50 company records using random integers between 1 and 100 as the ID. And I'm going to use the Faker library that I covered in a previous video. So let's take a look at how I'm going to generate this data. So I'm going to import random, and I'm going to import Faker, or the Faker library, and in particular I'm going to import the company provider that's available in the Faker library. And then I'm going to write this function called generate fake companies, and I'll pass in, optionally, the number of companies that I want to create. So I set up my Faker object, I add the provider of the company. If you don't know what this is, you can take a look at the documentation. It's really good for that particular library, or go and check out the video that I've done in the past on how to do that. But this will basically create fake company names. Now, I want to generate company IDs in the range 1 to 101. So what I'm going to do is I don't want to have repeated IDs, right? So I cannot just do a rand int because I may get a repeated random number between 1 and 100. So this is why I did this range, and then I do a sample of the range, and I sample whatever number of companies I want to create, 50. So this gives me a unique random ID, and I'm going to assign that in this dictionary here to the field, to the key ID, and then I'm going to generate a fake company name and assign that to the name key in the dictionary. Then I'm going to seed both the random and the Faker libraries. So this way I have repeatable results. Obviously in production code, you would not seed. You do want true random, or at least true pseudo-random. You wouldn't seed. Here I just want repeatable results. And then I'm going to generate the fake companies, and I will print out the first 5. Okay. So this isn't writing anything to the database yet. This is just essentially creating this. As you can see, we have this company here, ID of 50, the name is Chang Fisher, this ID here, the name, the ID, the name, and so on. So now it's time to save those companies to our database. And for that, we're going to use, again, our cursor, but this time we're going to use this thing called execute many. And we're going to insert into companies the field ID and name, and the values are going to be passed in by name as ID and name, and then we provided this companies, which is a list of dictionaries with the same keys, ID and name. It needs to match those two over here. Not those two. Those two are the name in the table. This is the name of the variables that it's going to look for essentially as keys in the dictionary. So when we execute that, again, I don't care about the result. I don't get an exception. What we can do is we can just go ahead and retrieve 1. So I'm going to execute this select count star from companies. I just want to count the number of records in companies, and I'm going to fetch the first result, only 1. I only need 1 since select count star, of course, only returns 1 result. And as you can see, it tells us we have 50, right? Now, one thing to note, of course, is that we made ID a primary key, which means the database will reject an insert if there is a conflict. Let me show you that. Let's try and insert another one. We know that 50 is in the database, not from this count here, but actually from this ID over here, right? So we know that 50 has already been taken up. So if we try and insert into companies the value 50 for ID and then test for the name, that's going to fail. And the specific type, exception type, is going to be an integrity error. As you can see, indeed, we got an integrity error, and it tells us the error message, the unique constraint failed for the company's ID. Okay, so now that we have our database and some pre-populated data, let's write a function that will create a new company and insert it into the database. So basically very similar to what we did over here with the execute of insert statements. The catch, though, is that we want the function to assign a random ID between 1 and 100 to the new record. So I would write the function this way. So we're going to create the company. We're going to pass it the database cursor. I'm just going to keep things simple here and pass it as an argument, and then just the name that we want for the company. But I'm not passing in the ID. What I do with the ID here is I generate a random number between 1 and 100. And technically, if I want 1 and 100 inclusive, 1 to 101. Actually, no, sorry, this is randint, not a range. So 1 to 100, it is inclusive of the endpoints. I'm going to put a print statement saying I'm creating the company with that ID, and then I'm going to execute this insert statement where I'm going to pass in the ID and that and the name. Okay, so this is the function. Now I'm going to reset my seed to 0. So now I'm resetting the pseudo-random number generator, and I'm going to create a new record. I'm going to call create company. I'm going to pass it the cursor, and we'll just pass in the value test. Now what's going to happen is that the very first time that we run this, it's going to generate a company ID of 50. This is why I set my random seed. And so when I execute that, you'll notice that it's trying to create a company with ID 50. And of course, as we know, we get this integrity error. So this function call failed with an integrity error. And it will keep failing. If we try it again, if I call it again, I'm not resetting the seed now, but now the second ID it tried was 98. That was the random one that it came up with. And unfortunately, 98 is already in the database. And this is why I populated 50 records. So we've got a 50-50 chance of hitting an existing ID, kind of, right, roughly. So the question is, well, how do we find a free ID? And there's different ways of doing it. Obviously, as I said, this is a bad design. But let's say you're stuck with that. And really, this is just to show you how Tenacity works. So how could you approach this? Well, we could certainly use a while loop or some other mechanism to do that directly in the code. We'd do a while and then we'd keep trying with the random integers, right, one after the other, until we happen to find a random integer that works, right? So we could write that using a while loop using Python code. And if you only need this in one place in your code, maybe that's fine. That's a simple approach and that would work. Yes, it's a brute force approach, right? But now let's consider how we can do this using Tenacity. And then we'll think about where it might be useful in other scenarios. So one way that we can do is basically instruct this function to keep retrying. No matter what the exception is, just keep retrying indefinitely and, with no pause between the retries. That's the most basic we can do. So we're going to take our existing function, and all we need to do is we need to decorate it. So we're going to take from the Tenacity module, we're going to take the retry, and we can just use it like so. And then we decorate our function, our same function, right? It hasn't changed. Now I'm going to reset my seed to 0, and I'm going to call the same thing that I did here. I'm going to try and create this. Now, as we know, when we set the seed to 0, at least the very first two are going to fail. 50 is going to fail, 98 is going to fail. So let's see what happens. And as you can see, indeed, 50 failed, but now it's retrying automatically. Then it tried 98, tried a few, and eventually it found one that wasn't in use, right? It found this ID 94, and so it was able to insert that into the database. So this was just kind of a blind retry, very easy to apply, right? But the problem is that, it's not good to just retry a function indefinitely like so. Essentially, you're potentially opening yourself up to an infinite loop. So obviously we want to have stop conditions, right? Or we want to only retry if certain exceptions happen. And that's the first thing we're going to look at. Because what happens if the insert that I'm doing here is not an integrity error? It's got nothing to do with this ID. Maybe it's something else. Maybe there's a lock on the table and I'm not allowed to do inserts. Or maybe it's something else that's going on. Maybe I'm passing in bad values for the name. Maybe there's, this validation checks on the name and it's failing that, or whatever it is, right? We don't want to retry in those cases. We want to actually get the real exception out when we call create company. We only want to retry if it was an integrity error. And this is where we can use Tenacity's decorator, but this time giving it a parameter, telling it we want to retry only for certain exception types. So again, we're going to take our code. I'm going to copy that. It's essentially the same as what we had before. All right, so what I've done here is now I'm using the retry decorator, the same one we just did, but I'm specifying this retry. And this is basically saying, when should Tenacity retry this function, right? If this function raises an exception, under which conditions should it retry? And this is where we say retry if the exception type is an integrity error. Otherwise, don't retry. Okay, and I've slightly modified the create company. What I'm doing here to try and show you that other exceptions are going to not be retried. I've got code here that raises a value error. So I'm going to try and create this, and then if the ID is odd, right? So we know that the first few are going to be even, and eventually here at 63, if we have the same sequence of random numbers, it's going to raise a value error. And then otherwise, we don't do the value error. We try and do the insert statement. And of course, the insert statement is going to fail occasionally, right? And this is when this will then retry, because this will give us an integrity error if the ID was not unique, and then it will retry. But if it gets the value error, not going to retry. So let's just try that. So again, I'm going to reset the seed. I'm going to create this company just as before, and let's see what happens. As you can see, we get 50, 98, 54, the same sequence that we had before, right? And these were even, so they did not raise a value error. But as we know, they did raise an integrity error. So we hit a retry. But at some point, this ID became odd. So it became, 63, I think, or something like that? Yeah, 63. So when it tried to insert 63, we actually raised a value error. And you'll notice that the error actually came back to us, the caller of this function. The retry did not happen. So very, very useful when you want to retry only based on certain exception types. Now, we also need to worry about setting retry delays very often, and just as importantly, limits. We don't want to retry indefinitely, and especially if it's API calls where you're rate limited, you may not want to retry immediately. You may want to wait a little bit, wait a second, wait 2 seconds, whatever it is, and then do the retry. These retries are happening one after the other, right? No pause, as fast as it can. And very often we want to throttle the rate at which the retries are happening. So there's different ways that we can define waits. So one way, let me show you this first one, is to wait basically a fixed number of seconds between each retry. And so here we specify again the retry just as before, the integrity error. So we're only going to retry on integrity errors, but this time we're going to wait 1 second between each retry. So let's define that, and let's run this same code again. And as you can see now, there's a delay, right? It's not happening as fast as it used to. But everything else worked the same way. It's just that we've introduced a delay in it. Now, there are many other wait specifications included in Tenacity, including things like random times, for example, with specified limits. So that's another one that we could do. Let me show you that one. And there are plenty available. I'm only going to show you a few, kind of the more important ones. So here, I'm just setting the wait to the wait random. I'm going to say I want to wait a random amount of time, at least 0.5 seconds and no more than 2 seconds. Right? So if we do this and run this again, just keep a close eye. I'm not going to change the video speed. Keep a close eye on this and you'll see that the retries will kind of vary, you know, in terms of how fast they come. You saw that one was quite fast. The other one was slower. The first one was quite slow. Okay. Now you may be wondering, well, why didn't we get the same sequence as here, right? Where every time we reset the seed, we got the same ID sequence. Well, this is because we now have also the Tenacity library using the random pseudo generator. So it's kind of, you know, we no longer have a sequential call to random when we're doing the random ID, right? When we're doing this over here, this is also being interspersed. So hence why we don't get quite the same sequence. Now, when we deal with rate-limited APIs, for example, we often use what are called exponential backoffs. And this might be things that you use also in other cases where maybe you have, you know, a connection to a server somewhere that you know is flaky and you need to retry, but you want to have a delay, but you want that delay to keep increasing as you retry. So the first delay might be 1 second, then 2 seconds, then 4 seconds, right? This is called an exponential backoff. And again, Tenacity allows us to do that. So let me show you how that's done in Tenacity. Again, as you can expect, it's very simple. The wait now is this wait exponential. And so we have here this multiplier, this min, and this max. So the way exponential backoffs work here is that the first retry waits this minimum number of seconds. And then the second retry takes 2 to the power of 1 times 1. 2 to the power of 1 because it's the, you know, the first retry, for example, or the second retry. So it's going to go 2 to the power of 1, 2 to the power of 2, to the power of 3 times whatever the multiplier here is. Okay? So again, if you want more details, just go and look in the library documentation. They probably explain it in more detail. But we do not want our delay, our wait between subsequent retries to exceed 10 seconds. So it's going to do an exponential backoff. It's going to keep increasing the wait times until it reaches 10, and then it will just stay at 10, you know, again and again and again. Now here, what I'm introducing as well is this stop parameter. This is because I do not want this to run forever. I want to, let's say, only do 6 retries. Again, very typical when you're working with APIs and you're making calls. You don't want to retry indefinitely, right? That's just going to hang your application potentially. You want to retry a certain number of times before you just give up and say, I just can't, you know, I can't connect. I'm getting timeout after timeout after timeout. I can't do it, okay? Or you're getting hit by rate limits again and again and again. But this is why the exponential backoff is great for rate limits, because that allows you to start increasing that time that's, you know, between retries. Okay, so this is very simple. And now we can try and running that same code as before again. And you can see we have now the delays are increasing. You can see it's getting longer and longer between each retry. I'm just going to let it run. I'm not going to pause the video. It's still running. There we go. Now it finished. So you saw how that exponential backoff was working, right? And at the end, it was just 10 seconds every time. But what happened? Well, we did get an integrity error. That's because we said now stop after 6 attempts. And so we did get 1, 2, 3, 4, 5. On the 6th attempt, we still got an integrity error. And at that point, Tenacity said, well, my limit is 6. That's it. We've reached the limit. So whatever that error was, we're going to, you know, throw that back. Now, I'll show you later how to actually access the actual exception that we got because what happens is that Tenacity raises a retry error. And it tells us that this was an integrity error. And if we look at the stack, we can see this was an integrity error. But how do we recover from this retry error? How do we recover the original error from that last retry? If you stick around, I'll show you that towards the end of the video. So here we stopped after a certain number of retries. What we could do instead is to say, I want to stop if I want to have a maximum amount of time altogether, total, right, cumulative, before you stop retrying. So you may say, I want to keep retrying, maybe with or without exponential backoffs, it doesn't matter. I want to keep retrying at 1 second intervals, but I don't want to keep retrying for more than 20 seconds, for example. Again, Tenacity gives us that capability as well. So let me show you how that's done. We basically just have to say that the stop is a stop after delay. So here I'm saying stopped after 10 seconds. So if the retries, starting from the beginning with the retries, if this is 10 seconds or more, stop retrying. Okay, so this is basically kind of an approximation to the maximum amount of time that this function is going to take to run. So let's go ahead and create that. And I'm actually going to time how much it takes to run. So here I'm going to import perf counter from time. I'm going to start. I'm going to create my company. It's going to do the retries. It's going to use here an exponential. And I'm going to only retry it just as before if it's an integrity error. And then I'm going to look at the total count, right? The total time. So we'll see both how many times it actually attempted to retry and then when it stopped. So it's still running. Okay, so it stopped after 15 seconds. Why 15? We said 10. Well, remember, this is this exponential thing. So by the time it started this last retry, it hadn't hit 10 yet. But then after that one, it definitely hit it, right? So you could even try doing with a 5. You'll see what happens. It's good. So that with an exponential back off is going to be approximate. But let's do 5 and let's see what happens. And you can see it stopped after essentially 7 seconds, right? So this is why I said this stop after delay is a cumulative time. But of course, if this iteration here, if this retry hasn't, is still below 5 seconds, it's going to do the next retry, and that could potentially take you over the 5 seconds. Now you can actually view the retry stats. So if you want to see what happened, you can say create company. That's the decorated function now. So create company. And we can look at the retry statistics. And it will tell us some information about that. It will tell us the start time. It will tell us how many times it attempted and, how long it took essentially. And then the delay since the first attempt. So that's usually, interesting to know basically on the attempt number. You may want to use that in logging. Speaking of which, Tenacity also has hooks for putting logging in terms of before and after retries. I'm not going to get into that in this video. Go take a look at the documentation, but you can hook logging into all this. Okay, so this was a retry based on an exception type, the integrity error. But we can also have lots of other ways of defining when does something get retried. One of which is the actual return value of the function. So let me show you that. I'm going to change the function a little bit and let's see. So retry, we're going to retry, and now we're going to use this method here, retry if result. And this takes a predicate function. So it's a function that's going to receive the result of calling create company, and it should return a true or false. If we return true, the retry will be tried. If we return false, the retry will not be tried. Okay, so basically this is a predicate function. It returns true or false. And if you want the retry to occur, it needs to return true. So here, I'm going to say, well, retry if the result is none. So I want to keep retrying this function until the result is not none. So there's no retry limit, right? This is going to keep trying indefinitely. So potentially an infinite loop, usually not a good idea to put that into your code. So here I've just modified this function a little bit. instead of letting the exception, the integrity error exception, bubble up and then using the retry based on that, I'm actually going to intercept that error. And instead of raising the error, instead of letting that error just raise, I'm going to return none. And again, before you flame me in the comments, this is bad design, this is bad Pythonic code. You don't return a special value to indicate that an error occurred, right? You raise an exception. That's what exceptions are for. But here it's because I want to show you that we can actually do something based on the return value of the function. So let's go ahead and run this, and I'm just going to call it. Again, I'll reset the seed. And as you can see, it called it. It did everything we did before, right? The same, it had the same behavior, the same sequence here. And then eventually we found a number that could be inserted into the database. That ID didn't exist already. And it retried based on the fact that when there was an integrity error, I returned none. And the predicate function here was testing for none and returning true if it was none. So this allows you to have some very, very flexible ways of defining retries. Now we can also retry based on a specific exception value, like for example an API rate limit that we get. So obviously everything I've shown you here can be applied to other situations, right? Including API calls. Now I don't have access to a public API with a low rate limit to show you an example. But basically the idea is that your function making the API call will raise an HTTP exception. You can then specify the exact HTTP exception you want to perform retries with. Now in general, rate limit HTTP exceptions are 429s, but various APIs may choose to report back a different error code, so you'll have to check your specific API that you're working with to see what exception, what error code do they return when you've hit a rate limit, and you'll have to basically use that. So the thing here is that raising an HTTP exception from the requests will raise an HTTP exception for any HTTP errors, not just a 429. But here we only want to retry if the status code was 429. If it was a 404, for example, we don't want to retry. That's something else. That's a different problem, right? We only want to retry, let's say, if we hit a rate limit. Now, to handle this, you could either trap the exception inside your call that's making the request, trap the HTTP error, see if it was a 429, and then raise a different error, and then use that as the type, as we saw we can do with exception types. Because Tenacity on its own doesn't provide us a way to, just like we are here, we could specify a custom function based on the result. We don't have the same thing to specify a custom function based on the actual contents of the exception. So HTTP error with the requests library is the HTTP error, but we need to know what that status code, what that error code is. And Tenacity doesn't give us that by default. So let's just see what that HTTP error looks like in the request. So again, I'm going to import another library, this time the requests library. And we're going to, let me just copy paste this. There's no need for me to type all this stuff. I'm going to make this call to google.com/junk, which is basically an endpoint, a resource that does not exist. Then I'm going to raise for status. Now, raise for status is going to raise. Doesn't matter what the specific HTTP error was. If it wasn't a 200 level, if it was a 300 or a 400, actually I don't know about 300s, but 400s and 500s certainly, it will raise this HTTP error, no matter what the code was. Okay, and we can look at what the status code is in this exception that we get, in the HTTP error exception we get from requests, we can look at the response status code. Okay, so that's what I'm doing here. And as you can see, I printed the error message, tells us this was a 404 error, and then this was the actual status code over here. And this is what we're going to want to retry on, based on what this value of the status code actually is. So to do that, we're actually going to use an abstract class that Tenacity provides, And I have the link to the code of that abstract class in the notebook if you're interested to see, because there is really no documentation about this in the Tenacity documents, at least none that I could see. So if you did find something in the Tenacity docs that I missed, please add a comment below and let us know where it is, because I certainly couldn't find it. But if we look at that, basically, we can use this retry base abstract class to create our own class, which will then be able to inspect, to basically create our own class that's going to replace this exception type thing, right? It's going to replace it with our own code. And this you can make whatever you want. So this is kind of the, the ultimate in flexibility, because you can really do whatever you want. In this case here, we're just going to check that the exception was an HTTP error exception and that the status code was 429. So essentially, we're going to create a custom retry handler. And again, I'm just going to copy paste that from the notebook. And here's how it works. So from Tenacity Retry, we're going to import the retry base. We're going to create a custom class. And we can name it whatever we want. But I'm using here a non-Pythonic way of naming the class, and you'll see why in a second. And then we inherit from retry base. This is an abstract class, and one of the things that we should define is this call. So whenever we do this, we need to implement the call method, which means that instances of this class, retry of rate limited, will be callable. And when they get called, they will be passed in by Tenacity this object called retry state. And the retry state has an outcome. And it also has this property called failed. So we can see if basically was the outcome of calling this function a failure or not. So from that, if that was true, then we can grab the actual exception by looking at the retry state outcome exception method. We call that method, we get the actual exception back. And now we need to test to see, do we want to retry? Well, remember how we did it with the value? If we wanted to retry, we had to return a true value. If we didn't want, we would return a false. We used a predicate function. Well, call here is going to return a Boolean. It's the same idea. It's the same principle. It's going to be a predicate callable, essentially. So we're going to check to make sure that the exception was an HTTP error and the status code was 429, which in requests is actually you have an enumeration, I don't know if it's an enumeration, but certainly you get too many requests. You don't have to use the hard-coded value 429. That's essentially what it is. So I'm only going to return true from this if it was an HTTP error and the status code was 429. Otherwise, I don't want to retry, and it will therefore return false, and that's it. Tenacity will not retry. So as you can see, this is very, very powerful because you can kind of do whatever you want, right? Here I'm just looking at if the outcome failed, but you could write whatever you want here, whatever test you want, and decide whether you want to retry or not. So this is like complete extensibility for Tenacity right here. Okay, so now that we have this, let's go ahead and actually use it. So I'm going to define a function called makeCall, which is going to, basically here I'm going to mock an HTTP response with a 429. I can't hit an actual API to show you that, so I'm just going to essentially fake it. So I'm going to go ahead and create a response from requests from the models. I'm going to set the status code. I should set other properties as well, but the only one I'm interested in is status code. And I will set it to this 429. And then I'm going to raise this HTTP error that has this response. Okay. So basically I'm faking it here. But what I want to do is I want to make this retryable. And I want to retry when we have a 429, but not in other cases. So what I'm going to do here is I'll just copy paste it again. You'll see that my retry is retry if rate limited. So this is why, by the way, I used this in a non-Pythonic way. This class name is really not Pythonic. Usually we use, capitalization, camel case. Here I'm not, because this is more consistent with how things are done with Tenacity in general, right? If we look at some of the other ones, retry if result, right? So I'm just trying to keep the same thing. So we have retry if rate limited, and we have nothing that we're passing when we're creating the class. We don't have an init, so it doesn't actually take any arguments. You could, if you wanted to, and actually pass arguments, but then you'd have to define the init and then, do something with those arguments. And then I'm also going to put a stop, right? I don't want this to continue indefinitely because this code here is just going to keep raising a 429. So this would be an infinite loop, so I need to stop it at some point. So let's go ahead and execute that. So now we've got that created, and now let's actually make the call. So we make the call, and here I'm going to catch a retry error. So at some point, because we're going to stop after 3 attempts, we will get this retry error. And remember, I told you in the beginning, I was going to show you how to actually get the actual exception that caused this. Not the actual retry exception, but the exception just before that. Just like that integrity error that we were doing before was the one that actually caused the whole thing to fail because we'd reached the maximum number of retries. So to do that, we take a look at this retry error, and we look at the last attempt property. And this has a method called exception that we can call to actually get that exception. And that exception is going to be that HTTP error. So now we can look at the response status code, right? Just like we did before with the regular HTTP error. So let's run this. And as you can see, we get the retries, retried 3 times, and on the 4th time, we get this retry error. So that's what we got, right? This was the actual exception. It was the retry error exception. But then we were able to dig into it and actually retrieve the original exception. So there's plenty more that you can do with the Tenacity library. I mean, so far we've been using just this decorator approach, and certainly it's probably one of the more common ways of using it. But there's also another way that you can use it where you're not using decorators at all. You can actually just put that retry directly inside your code without a decorator. You're just going to essentially use a context manager. So let me show you that, because that's kind of interesting and that can be useful at times as well. So again, I'm just going to copy paste this from the notebook. So I'm going to create this counter object, this global counter. And here, this is where we set up essentially the retrying and the conditions for retrying. So when we retry, we're going to retry a certain number of times. Those are called attempts. And for doing that, we're going to do a for loop, and we're going to use this retrying class, and we're going to instantiate it with a retry and a stop. So this is very similar to the arguments we were passing to the decorator. Here, we're basically setting up an object, and then we're iterating over that object. So that object's an iterable. And this is the attempt. And now we can say with the attempt, do something, right? And so what's going to happen is that it's going to keep retrying. If we hit that the exception was a value error, it will actually retry. Otherwise, things will continue happily on their way. So let's try that. As you can see, we get attempt 1, 2, and 3 because I raised a value error when the counter was less than 3. And then we had a success. It passed, so it didn't have to retry. So the iteration essentially was stopped at that point, right? So we just keep iterating in this object, in this iterable here, until it tells our code, oh, this iterable is done. Essentially, it raises a stop iteration exception, right? So let me show you a variant of that. It's actually the same retry code, but what I'm going to do here is I'm going to raise a type error. So I want to show you that here, again, just like we did with the decorators, we're only retrying it if it's a value error. So the first 3 times we're going to retry because it's a value error, but then the next thing is going to be a type error. That doesn't get retried, even though my stop attempt is 5, right? I've jacked that up. So to 5, but I'm raising the value error only 3 times. The raised type error will be the 4th attempt, but that's not going to retry. And indeed, as you can see, we got the type error over here. So this is another way where you can use Tenacity in your own code, and it doesn't have to be a decorated function. You can just use it directly in your own code. Personally, I much prefer the decorator approach. I find that easy to understand. This, you just have to wrap your head around this a little bit, realizing that you're basically building an iterator up using retrying, and you're going through this iterable until the iterable says, I'm done, right? And essentially, that's what that is. And of course, now you have to use the with attempt, because that is what allows it to communicate back with the iterable so it knows when to stop. Because as you can see, if we don't have the with attempt, if we don't have the context manager, then things don't work correctly. All right, so this is why I'm saying it's a little bit more difficult to kind of understand what's going on, but it's still really straightforward. So Tenacity also allows you, as I mentioned earlier, to hook up loggers for both after and retry, as well as many other options for retry conditions, for delays, including jitters, and a lot more. Just go ahead and look at the documentation. You'll see, all the options that you have for stopping. You've got, the stop after attempts, the stop after delay. We talked about that. You can actually even or and your conditions, right? So you can stop after delay or after attempt. So it's very, very powerful, right? In things that you can do. You have the weights. You can weight random. You can weight exponential. We went through that. This is their documentation here for what the exponential backup means. But you can also just do a Google search for exponential backups. You can also combine them just like you have. So like your weight could be a fixed weight plus a random, right? So there's lots of kind of nuances that you can do here, right? You can build chains of backups. As I said, it's a very, very flexible and powerful library. In terms of whether you want to retry, there's all kinds of things. You can retry if exception type, if not exception type, unless exception type, if result, if not result, and so on, right? So go ahead and take a look at that. I highly recommend using this library. It's very useful, very easy to use. And yeah, it can get complicated. You can do a lot of, really fancy stuff with it. 80% of the time, 90% of the time, though, you can just use what I've shown you in this video. That is more than enough to cover most use cases for retries. All right, thanks for watching and happy Pythoning.